Programming is not hard. You just need real context. Allow me to explain to you completely and in context what relational databases are and how they work. You might have already heard that databases are like spreadsheets. They have rows and columns. But that is all you should visualize, just rows and columns. Spreadsheets emphasize cells and have formulas like sum that can dynamically generate cell values. Database tables focus on relationships with other tables. To establish a relationship, two tables will share some common piece of data. Each table will have a column with the same information so that you can say, join these two tables on that column. This is a different trick than dynamically calculated cells in spreadsheets. But the underlying data structure is the same grid, rows, columns, cells, or fields. Usually, at this point, school textbooks talk about different types of joins or relationships that you can establish between tables. But there's only one type of join that you should remember when starting out. The left join, or the one-to-many relationship, which is like having a folder, which is the one, with files, which is the many. Now, before we go any further, we need to understand what we are doing. Continuing to speak in abstract terms of tables and rows and fields or cells is useless for understanding databases. You cannot understand databases without a reason, a picture in your mind, an idea. And our idea is to create an internet version of a music player that supports multiple users that can create their own playlists and add their own music. The first thing we must do is to create a starting point, and that is the notion of accounts. This is the main database table, our anchor to ground all the conceptual system stuff. The only thing this table really holds is a user ID. Again, because it is the root to all our concepts ahead. But just in case you ever want to support multiple logins, an account table would help you accomplish that. Gmail has a feature where you can combine inboxes under a single account. That is how a single account would develop multiple users. Now, you should know something kind of weird about the one-to-many relationship between tables. If we were just to run a left join or establish one-to-many relationship here, we would get multiple rows for the same account with different users. So rows are multiplied based on whatever entries exist in the second table that we are joining. If you had one account with two users, the query would return two rows. They would have the same account number, but different user information. It makes perfect sense. But it is unusual that here we have a table that may only have two accounts, though multiple users, and when we query that table with a left join or one-to-many relationship, we will have more than two rows returned because we will be gluing stuff with that other users table. It's just something to remember. it's okay to get more rows than the accounts table holds all by itself. School professors would, of course, have a huge problem because we are violating the concept of database referential integrity. That is, if you just have one user per account, you should totally use one-to-one relationship. But we don't care about that. This would be pretty cute, but nobody has time for this. We just use a left join everywhere. This way, we create a consistent tree, a folder with other stuff in it, and all the other stuff is also a folder that can have other stuff in it. The account is root. It may contain multiple users. The account is root. It will probably contain multiple playlists. Now, when you get into playlists and think of it as a new root, then it will absolutely have multiple songs. Now, your songs will have multiple ratings. Bob gave a song thumbs down. Alice then came back a day later and gave a song thumbs up. So even though there are many types of relationships, like 6 or something, that you can establish between tables, just stick to one-to-many, and all the people that will say that this is terrible advice, they don't matter, because you know better. And it is very useful to imagine that you are building a tree, a nested tree of tables. You have this main table, accounts, and then you start piling stuff under there. But that stuff can also be linking to other stuff. So just like the playlist table that is under the accounts table has songs, you can also create other things, such as articles table that then has comments, that then comments have ratings. Relational databases are capable of far more. In fact, they are capable of infinite complexity. But in the real world, when you are building your website to make money, to get sign-ups, to get everything worked out real quick, to get going, you just need the one-to-many relationship and you just move on and get over it. Now, we violate another rule, the do not repeat yourself rule, because we are going to put account ID into every table. User, playlist, songs, rating, and if you're working in another app, articles and comments. Account ID everywhere. Because we are working in the real world scenario of making a minimum viable product, account ID is extremely special here. Because as your user is moving around the user interface, they are always submitting that account ID. That information is always present in the interaction between the user and the server. You should probably use JSON Web Token because it is tamper-proof and useful and pretty new and pretty cool. Later on, as you get more comfortable with these ideas, in your second or third or fifth web application, you shouldn't use sequential numbers for account ID or user ID, but you can use it elsewhere. Just in case your account ID leaks and you are still learning web security, you don't want anybody to be able to just increment that number and get information about some other users. So you have to use a UUID number generator. This is costly in terms of memory usage because SQL servers usually save memory by using a single integer that they just keep on increasing. So it's very memory efficient. And the UUID string is 64 characters long, I think. But it is universally unique. So even if a hacker finds some way to break into your website, they will not be able to guess the user ID of another user. So even though we have this sturdy tree structure of nested tables here, to get all the songs, all you need is one little query. You just say select all from songs table where account ID is, and then here you plug in the account ID number. Later, you can run a query to see if the account is active and maybe create something more complex, where you combine account table with user table with playlists table and the songs table, and here you will get all the songs with account information. Presumably, this would be useful for some internal company report or some graph or statistics. That functionality is still here, but to make the website API, you don't need it. You don't need to write complex queries just to get some information about an account, because you put the account ID everywhere. You can query any table with just that account ID. As to IDs in general, all tables have a unique ID. And that is one piece of information that you should never change. Oh, you can change email or mark an account disabled or deleted, but you never actually delete it. But you never need to alter an ID because it's always unique. It's just there is no reason for it. And even if you invented a reason, you should never do that anyway. That's one rule that shouldn't be stretched or broken. Now, to make the website go, you now create beautiful function names that you will use for your API. So now we are moving a step higher. We are creating API functions that may contain multiple calls to the database. We never want to interact directly with the database from the perspective of a website. JavaScript, the only language that works in the browser and on the server, is the only language that you need to learn. Don't let anybody else convince you otherwise, at least not at first. It also has some interesting and very flexible tricks. It is not a strict language, and it allows you to do a little bit of metaprogramming, and you should always take advantage of that because it helps you program and move along faster with making less bugs. Let me give you an example. When working with some part of your API that, for example, is related to a user, JavaScript allows you to mark your functions for export without actually making an array that lists all the function names, where you always have to remember that you need to update the array after adding a function to your API. JavaScript allows you to say import all as playlist from playlist.js. So you are never creating a list of functions. So when you add an API function, such as add song to playlist, you hit save, NodeMon restarts your server, a feature that's actually available in Node. And that function is now part of your API automatically. You never have to put it anywhere else. You just create the function and now it's part of your website. As I noted, these functions are conceptually higher than your database stuff. So your sign up function may execute 2 or more queries. Add account, where you grab the account number that the database generated for you, and then add user, where the first thing you do is save that account ID so that now you can relate account to the user. And then, of course, you put in the email, the password, the first, last name. You can also take the extra step of marking your records as deleted or not. This way you never have to delete data. You just mark it deleted and it still stays there to preserve database integrity and help you track history or whatnot. Encrypt or hash your password. Don't let it sit there out in plain text. Encrypt means that you have a master password for all your user passwords. It is an idea, but it is not a good one. It is creating an unnecessary piece of information. The password for passwords. Sometimes when you are busy, some environment variables or files or dot files or configuration files may be unnecessarily saved to a public repository, and you don't want to deal with that. If you hash your password, you still get an encrypted string, but now even you can't decrypt it. It is a one-way encryption. To check if the password matches during login, you encrypt the new password that the user sent in again, and then compare the 2 encrypted strings together. If they match, it's the same password and you let the user in. Now, to further elucidate on the subject of metaprogramming JavaScript, all these beautifully named functions become your automatic API when you wrap them in a JavaScript object proxy. An object proxy gives you the ability to intercept the call to the API and either say, "Hey, that function does not exist, here's an error," or execute it if it does. To create the API object that you apply the proxy to, you just use a spread operator on the objects returned by import all as playlist from playlist.js. In this case, the playlist object is now assigned to your main API object, and thus your API object now features all the functions you marked for export in playlist.js. Super cool. You never make a list of what you're exporting. Just the moment you stick a new function in there, it becomes part of your API. Now the metaprogramming component gets even more fun because you can deliver your API in multiple ways. You can have an HTTP route that talks HTTP. You can have a WebSocket that speaks in the WebSocket way, and you can even create a command line interface where a subcommand is named the same way that your API functions are named. So you have multiple ways of executing your API depending on what you're trying to do. This really helps with administration. As to security and authentication, at first you present only sign in and sign up, but you always check for an authentication property on the incoming object into your HTTP or command line or WebSocket endpoint. Because once authenticated, You will then apply all the other functions to the API object, like upload song or create playlist. When executing sign-in, you will actually authenticate twice. Do not optimize this. Hoisting your API from anonymous to logged in and then performing sign-in tasks are two different things. As a result, this grants you the ability to execute add playlist from the command line without ever signing in, which wouldn't make sense on the command line. Rule breaking makes your programs consistent, easy to remember, and quite powerful. In short, you now expose your API as a WebSocket, then via HTTP route, you should probably call it v1 as in API version 1, and use the npm commander module to expose your API on the command line just in case you ever need it for administration. You don't have to put authentication information into every command, just set it in an environment variable or a dot file. And now you are done. You have a headless API server. And now you go and grab user interface technologies, Svelte and Bootstrap. Here you create a UI, also in JavaScript, and you use HTTP or WebSockets to communicate with your API server. Now you are calling the neatly named API functions sign up, sign in, add song, which trigger one or more queries on your database and return the table data that you now can use in your interface. Here you are adding playlists, uploading songs, and have proper buttons and input forms where your users can now interact with the API by means of a graphic user interface. So, in summary, relational databases just need one relationship. Make it consistent, don't worry about it, think of it as tables, and sprinkle in some magic that violates all the rules, and you're going to be fine. It's okay. And as you continue creating these programs, you will learn more and bring in more SQL exclusive concepts into your programs. But you don't really need them to begin. The extras are for the SQL elitists, the SQL artists. And that's great. But again, you don't need it. Relational databases are sweet and simple. They are, in fact, your friend.